Hello and welcome to the JNCIS Enterprise Security Video Training Series. My name is Chris Frisch. In this video series, we will discuss all the topics outlined in the Juniper exam objectives for the JNCIS SEC exam number JN0-332. In this course, we will cover an overview of Junos security. We will cover zones, security policies, firewall user authentication, screens, NAT, IPsec VPNs, as well as high availability clustering and unified threat management. We will have some Q&A as well as short quizzes at the end of each section to test your knowledge. At the end of the course, we will provide you with a practice test to help you gauge your readiness for the exam. So without any further ado, let's begin our journey into the Junos security. In this chapter, we will cover an intro into Junos security. So let's begin at Layer 3. Routers are Layer 3 or IP address-based systems that forward packets. They are stateless, which means they do not keep track of the state of a session. And routers separate broadcast domains. They provide routing which is needed for connectivity outside of a VLAN, and Layer 2 switches do not. Traditionally, a router forwards packets based on a Layer 3 IP address. They use some type of path determination. Packet processing is stateless and promiscuous. Routers separate broadcast domains and provide WAN connectivity. Routing tables are built from dynamic routing protocols, static routes, or both. Routers alone do not provide enough security. This job is usually taken by a traditional firewall, which processes packets statefully, performs NAT, and establishes VPNs. Firewalls also can provide additional services such as IDP, or intrusion detection and prevention. Layer 3 packet forwarding. A traditional router is a promiscuous device that performs stateless packet processing. It is promiscuous because once it is configured, it immediately forwards all traffic by default, provided of course that some combination of static and dynamic routing is configured. Typically, a router operates only at Layer 3 and does not recognize any security threats in high-layer protocols. Furthermore, a traditional router operates per packet, which adds to its fundamental insecure nature, because it cannot detect malformed sessions. The network and the router itself are immediately vulnerable to all security threats. Firewalls process packets statefully, keeping track of source and destination IP, source and destination port, protocol, and session token, which is derived from a routing instance and a zone. Devices at the edge of a network must be able to replace non-routable addresses with public addresses and vice versa. Enterprise customer premises applications are served by the J-Series family of service routers, and in the case of larger enterprises, M-Series routers are used. Enterprise data center applications can also be serviced by M-Series routers. Firewalls can build VPNs to allow secure transit between private networks across the internet. To do this, it must authenticate the other endpoint, encrypt traffic to the other endpoint, and encapsulate it so that it can cross the internet. Compared to routers, firewalls do not let any traffic pass by default. You have to configure it to allow it. Routers allow all traffic by default. Junos security platforms combine the features of routers with the security of firewalls. They use Junos OS processing of routing, management, and others. Packet forwarding is packet-based, or every packet is fully inspected, but Junos security platforms add flow-based forwarding, where each packet flow is inspected, as well as policy and additional inspection, including ALGs and IDP, or intrusion detection and prevention. Junos security devices are logically divided into control plane and a data plane. The control plane is handled by a routing engine, which handles the chassis management, user interface, and routing protocol tasks. The data plane handles packets in a session-based format. Incoming packets are processed in a specific order: stateless policies and COS, session lookup using IP source, destination, source port, destination port, protocol number, and session token. If the packet passes stateless policies but does not exist as a session, it is processed as a NAT, route, and security policy. If it passes, a new session is created, and subsequent packets are then processed against screen options, TCP checks, NAT, ALGs, and security policies. Packet-based forwarding is stateless. Every packet is inspected the same way, disregarding session state, which means that the packet filters have to be applied in both directions. Session-based forwarding adds stateful inspection, allowing filters to be added only once and also allowing for separate data connections. Junos elements. SRX service gateways use the Junos OS as their base operating system. These devices deploy the industry-proven process of the Junos OS, such as routing process, management processes, device control process, and others. Additional building elements of the Junos security platform is session-based forwarding, thereby resulting in a strong suite of security features. Packet-based Junos forwarding. The Junos OS's basic control plane, routing protocol process implementation, per packet stateless filters, policy, and COS functions are all packet-based. Furthermore, other non-security related features such as all interface encapsulations and decapsulations use the industry-proven Junos OS. You can configure SRX service gateways using either the CLI or the JWeb interface, the Junos OS-based graphical user interface. Session-based forwarding. The Junos security platforms leverage ScreenOS software security features as well as its flow-based nature. The first packet entering the device follows a series of path and policy determination schemes. The Junos OS caches the session information, the creation of which is triggered by the first packet of the flow. The cache session is used by subsequent packets of the same flow and the reverse flow of that session. Using the flow module, which is integrated into the forwarding path, the hardware performs data plane packet forwarding. Because the Junos OS security platforms are zone-based, all IP version 4 packets entering the service gateway on an interface associated with an incoming zone. If a route changes but the interface remains in the same zone, the session remains intact. Junos adds many high security features including stateful firewall, VPN, NAT, ALGs, and IDP. Branch SRXs can selectively enforce flows as being packet-based. This allows higher scalability and can be configured on the CLI by creating a stateless firewall filter. As you can see in this configuration, we are in the Edit Firewall Family INAT configuration hierarchy, and we have a filter named Selective with one term from source address, the address, and then the term then packet mode, and applying it to the outbound interface with the Edit Interface GE001 Unit 0 Family INAT Filter Input Selective. When a packet is accepted and does not match any existing sessions, a new one is created. Default timeout is added, and the information is stuffed into a session table. If no traffic is recorded for the length of the timeout, the connection is aged out of the table. Policy changes that happen during a session are applied using the flow module. New packets that are a part of the session are forwarded using the new information. Routing changes are always applied, but security changes might not be applied. Sessions are created to store state information regarding a flow. Some characteristics can be changed. For example, the timeout of a session can be adjusted to keep the session's table from completely filling. Other checks can turn off the SYN checking or TCP sequence checking to allow for better compatibility with non-RFC compliant TCP stacks. Other parameters, such as maximum segment size, can be adjusted to enhance performance. Packet flow through the SRX service gateway is highly deterministic. Is the packet part of an existing session? If yes, forward it. If not, is the destination reachable? If yes, determine ingress and egress zones. Look up policy based on ingress-egress zones. If it is permitted, then add it to the session table and forward it. The Junos OS uses the Session VRF to provide stateful inspection and session-based security. The Junos OS forwards traffic between the two routing instances over logical tunnel interfaces. Because the routing tables of the two routing instances are separated, the Junos OS shares the routing information. The Junos OS shares the routing information between them by means of either a static or dynamic routing protocol. All traffic going in or out of the Session VRF participates in security zones and must pass through security policies to be allowed through. The configuration requires a selective packet-based firewall filter to place the traffic into packet mode. The operator configures the filter inbound on the logical tunnel LT000 Unit 1 interface. The Junos OS applies the filter as traffic ingresses the packet VRF. In-session maintenance. When a packet enters the system and does not match any existing sessions, the Junos OS creates a new session based on routing and security policy information. Once this new session is created, the software puts it into a session hash table for further packet matching and processing. Depending on the protocol and service, TCP or UDP, the session is programmed with a default timeout. The default TCP timeout is 30 minutes, and the UDP default timeout is 1 minute. Session cleanup. If no traffic matches the session during the service timeout, the Junos OS ages out the session and frees it to a common resource pool for later reuse. In-session runtime changes propagation. The flow module is responsible for propagating any runtime changes that happen during the lifetime of the session. This propagation allows new packets that match the session to forward using up-to-date information. Routing runtime changes always propagate into the session. Security policy runtime changes might propagate into the session in progress based on the corresponding security policy and zone configuration. We discuss this topic more thoroughly in later chapters. In-management session characteristics. Sessions are created based on routing and other classification information to store information and allocate resources for a flow. Sessions have characteristics, some of which you can change, such as when they are terminated. For example, you might want to ensure that a session table is never entirely full to protect against an attacker's attempt to flood the table, and thereby prevent legitimate users from starting sessions. You can configure the Junos OS to aggressively age out sessions based on how full the session table is by specifying the following options under the Edit, Security, Flow, Aging configuration hierarchy. Early age out. Specify the timeout value in seconds in which sessions age out once the high watermark value is met. High watermark. Specify a percentage of how full the session table must be. Low watermark. Specify the percentage at which the SRX device disables the early age out function and returns to the default age out time for the session. TCP security. The Junos OS provides a mechanism for disabling security checks on TCP packets to ensure interoperability with hosts and devices with faulty TCP implementations. Applying the following commands under the Edit Security TCP-Sessions configuration hierarchy can increase the throughput of the SRX device at the cost of security. Employing the No Sync Check command tells the Junos OS that it does not need to look at the TCP SYN packet for session creation. the no sequence check command disables TCP sequence checking validation. SYN checking and sequence checking are enabled by default, and the previous command disabled TCP SYN checks and TCP sequence checks on all TCP sessions, hence reducing security. This might be required in a scenario with customers or with applications that do not correctly work with these standards. However, you can disable the TCP SYN checking and TCP sequence checking globally and then specify these mechanisms on a per policy basis. So let's review. What type of packet processing do traditional routers provide? Well, traditionally routers process packets on a per packet basis. What type of packet processing do traditional firewalls provide? Well, traditionally firewalls process packets based on stateful flows. What are the two main differences between the Junos OS that runs the Junos security platform and the traditional Junos OS? The Junos OS that runs on the security platform uses session-based packet forwarding and by default does not allow any traffic to pass, whereas the traditional Junos OS uses packet-based forwarding and by default allows all traffic to pass. How is the first packet of a session handled differently from subsequent packets of the same session? The first packet of the session is subject to first path packet processing. Alright, that's it for this section. Now it's time to move on to a short quiz. Once you've completed the quiz, move on to Chapter 2. Thanks for watching.